Alright, welcome to today's lesson about explicit functions. So some of you might have heard the word explicit before, uh, maybe in a media context such as music or movies and stuff. Um, well, this doesn't mean that it has swearing and things like that, but instead, explicit means something's direct. It doesn't have a filter on it, there's no censorship on it, which for mathematics doesn't mean anything salacious. It just means it gets you the numbers directly without having to use a pattern to get things. And so, sorry to burst your bubble if you thought things would be a little bit more controversial here, but it's not. Sorry. But anyway, you're going to be writing explicit functions to describe a sequence today. And we're going to start with arithmetic sequences. With arithmetic sequences, it has a pattern of adding the same number every time or subtracting the same number every time, such as add 6, add 6, add 6, subtract 7, subtract 7, subtract 7. And this here is your formula for writing your explicit function for arithmetic sequences. You just write f of n equals your common difference times n minus 1, and then plus your first term. Something I want to mention right away, a lot of people want to put f here, especially after we did all the recursive function stuff yesterday. This will not have f of n minus 1. None of the explicit functions do. But you are going to use n minus 1 in the equation. So make sure you put common difference in front of n minus 1. And this doesn't mean d of n minus 1. It means d times n minus 1. So it's actual multiplication, which you'll need to do some simplifying with. So here's a few examples. This first one had a pattern of adding 6. It's actually the same example sequences that we've been looking at. And so the common difference is 6. The starting number is 2. And so I can fill it in. This becomes 6 times n minus 1 and then plus 2. But this is actually not simplified, and I want you to simplify it. The way you simplify it is by distributing that in. You get 6n minus 6 plus 2. And then you find that these two terms here are always going to combine together, and that'll give you a negative 4. And so this over here is the simplified complete form that I would like for you to put on your assignments when you're asked to get the explicit function. Let's look at a couple of the other ones. This one is subtracting 7 each time. So the common difference is negative 7. The first number is 40. And so I'm going to write out f of n equals common difference times n minus 1 plus 40. Again, you will need to simplify this. So you distribute your negative 7 to get negative 7n plus 7. And then you got plus 40 there. These are going to combine, which will give you 47. So if you look over here, it's negative 7n plus 47. On the third example here, it is subtracting 4 each time, so the common difference is negative 4. And the first term of the sequence is also negative 4. So when I go in and fill it in, I write f of n equals negative 4, my common difference, times by n minus 1, and then add negative 4, which is subtract 4 here. This is not simplified again, so you can distribute your negative 4n to get negative 4, distribute your negative 4 to get negative 4n plus 4, and then you got your subtract 4 from the outside. These are going to add out, and so they disappear, and you're left with just negative 4n on the right side there. So I would like for you to give it a shot on your own. Go ahead and pause the video and see if you can get the explicit function for this arithmetic sequence. Alright, hopefully you're able to catch on that this is adding 20 every time, which means our common difference is 20. And right here is our first term of our sequence. And so I can write this out. F of n equals 20 times n minus 1 plus 35. And this is, I'm just using the formula and putting in the numbers where they belong. This is not simplified, so I'm going to do some distribution here to get 20n minus 20 plus 35. And that's going to simplify a little bit. We got 20n, I keep writing 2n, plus 15. Ta-da! And now that you've kind of had a chance to do one on your own, and you've kind of seen this, I want to point out something. uh, this term here on the end, you can actually get this pretty easily and just kind of jump straight to your answer here if you recognize that 15 would be the term before the first term, right? If the pattern's adding 20, if you were to go back one term, you'd end up with 15. And so we kind of think of this as the 0th term. This would be f of 0 here. So even though the actual sequence doesn't start at 15, it starts at 35, you can think of a term before the first one. In this case, it'd be 15. And so if you recognize that, your formula can be also written out as just f of n equals d times n, or your common difference times n, and then you add your 0th term. So you can kind of think of this as a little shortcut to get to your answer. You do have to figure out your term before the first one, but it'll get you your answer a little bit faster. So let's have you go to the next one. Again, pause the video and see if you can get your explicit function. If you want to try using that shortcut, you can, or you can just use the formula you've been using. But pause the video and give it a shot. Alright, hopefully you caught on that this is subtracting 4 each time, so that's our common difference. Our first number here is 12, and if I were to go back a term, my f of 0th term would be 16. I mean adding 4 because I'm going left here. So if I jump straight to my answer here, f of n is going to be negative 4n plus 16. Or if you wanted to write out using the formula we've been using, you got negative 4 times n minus 1 plus f of 1. And not f of 1, plus 12, my bad. You can distribute your negative 4 to get negative 4n plus 4 plus 12, and these will combine to get you the 16. So here's our final simplified version. So there you go. That's how you write your explicit functions for arithmetic sequences. Let's do the geometric sequences next, and then we'll talk about some of the things on your assignment after that. So the explicit function for geometric sequences is this. You put the first term first, and then you got times r to the n minus 1 power. And this is an exponent, so you may want to note that this is an exponent. A common mistake is people just put r times n minus 1, and you're going to get a wrong answer if you do that. So let's look at a few examples. This first sequence here has a pattern of timesing by 4, which means the common ratio is 4, and I have my initial number of 2, so f of 1 is 2. So I'm going to put those numbers in my formula here. 2 goes in this spot, 4 goes in this spot, and you end up with f of n equals 2 times 4 to the n minus 1 power. So is that one? Let's look at another one. We got 40, 10, 10 fours, 10 16s, and whatnot. This is dividing by 4, so my common ratio is not going to be 4, but instead 1/4, because when you times by 1/4, that divides by 4. And then my initial value here is 40. And so look at this, I got 40. So now I have those two numbers. 40 goes first, and then 1/4 goes in my r spot here, which will give you f of n is 40 times 1/4 to the n minus 1 power. And if you want to write this up higher, that could help you a little bit, realizing it's an exponent. Sorry, just kind of this font here doesn't really show the exponential nature of it. But yeah, and then this last one, it starts at -3, it's times in by -2, so my common ratio is -2, my initial value is -3, and I just put them in. -3, initial value first, common ratio to the n minus 1 power, and voila, that's your equation. So something that makes these easier than the arithmetic one is these are already simplified. There is no need to do some further simplification with it, and that's because you don't have the n value, so you can't do n minus 1 and then do the exponent and then times by 2. And so these are as simplified as they are going to be. So there we go. So like for you to do is come down here and give this one a shot. Figure out your common ratio, figure out your initial value, and write out your function. Pause the video and give it a shot. So hopefully you caught on that this is timesing by -5, and so my common ratio is -5. And then over here, this is my first term of my sequence, that's my f of 1. And so I can write out my function f of n equals, initial value goes first, 4 times -5 to the n minus 1 power. So be very deliberate that this is an exponent. Please don't put it here. That would be times by n minus 1. That would be wrong. So make sure you put it as an exponent, and voila, this is over. That's it. There's nothing else to it, no simplifying. Go ahead and give this one a shot. Pause the video, see if you can write out the explicit by yourself. Alright, the pattern here is divide by 2, which means our common ratio is going to be 1/2. Timesing by 1/2 is the same thing as divide by 2. And then over here, we have our first term of our sequence being 2. And so I can write out my function f of n equals starting number times 1/2, common ratio, to the n minus 1 power. And ta-da, this is done. And there's no simplifying. So there you go. I did want to point out one other observation that's really handy, is realizing that this is exponential. This is your y-intercept. This is your growth factor, what you're timesing by. The part that's different is instead of just having x as your exponent, you have n minus 1. So this is exponential. And if you look at these arithmetic ones, these are linear. This is slope. You got your variable here, and then that's your y-intercept or your initial value there. And so that's something that's really handy when looking at these. Is arithmetic is like linear, geometric is like exponential. So there you go. Give it some shot. I'm going to do another video doing some examples from your actual assignment.